Hello everyone, welcome back to my channel, your go-to destination for unraveling the mysteries of cutting-edge technologies on Google Cloud. I am Mustafa, and today we are diving into the world of AlloyDB for PostgreSQL, which is Google's fully managed PostgreSQL-compatible database service designed for high-performance enterprise workload. In this lab, we will be performing essential administrative tasks to ensure the optimal use of AlloyDB for PostgreSQL. From examining database flags to setting up database extension, creating read pull rep instances, setting up backups, and monitoring the database in the AlloyDB console, we've got a comprehensive session ahead. Here's a quick rundown of what we will be doing. We'd learn how to inspect and modify database flag for fine-tuning performance. We're also going to add additional functionalities to our PostgreSQL database. We would also enhance our database read performance by adding read replicas. Then we'd ensure our data is safe by configuring regular backups. And finally, we'd keep an eye on our database health and performance metrics. So whether you are a beginner or a seasoned tech explorer, join us on this practical exploration of AlloyDB for PostgreSQL capabilities. Don't forget to hit the like button, subscribe, and ring that notification bell as we tackle these essential administrative tasks. Let's get started. As usual, we're going to start our lab. So we'll launch the lab with the required credits. And we are going to open this in an incognito window. So I'm just going to grab my password along with me. Paste my password here. I understand. So here we are on our Google Cloud homepage. After that, I'm just going to agree to the terms and service. And here's our Google Cloud dashboard homepage. Yeah, so we are good. So let's go to the setup and requirements. The first thing is to activate our Cloud Shell. So I'm just going to grab this command with me. So I'm going to click on this to activate our Cloud Shell. And after that, we are going to connect to our Cloud Shell instance. So I'm going to click on continue. So you can see to provision my Cloud Shell machine, and thereafter it will connect to our Cloud Shell instance. So here we are. So first thing, paste the command. So with this command, we are going to view the active accounts for this lab, which is this. Just going to cancel out of this. So this is the active account for this lab, and we can also view the active projects with Qwiklabs config list project. So this is our project ID for this lab. This is our account ID. So let's keep following the instruction. That's pretty much on the setup and requirements. So for task 1, we want to examine a database flag. So we have an AlloyDB cluster, an instance that has been provisioned for us when we started this lab, and we've shown how to deploy an AlloyDB cluster and an AlloyDB instance previously under AlloyDB database fundamentals. So a cluster has been provisioned for us, and we just have to examine the cluster. So the cluster is named lab cluster, and the instance name is named lab instance. So let's quickly take a look at those. Under view all products, so when you take this down a little bit, under database, you can see AlloyDB here. So let's click into AlloyDB. So I'm going to dismiss this. So this is our lab cluster, and this is our instance, which has been pre-created for us. Yes, so and it's in ready state. So you can see this is ready state here. So the next thing we want to confirm is to make a note of our private IP address So this is the IP address that has been created for us, and this is just the host name alone. So this is the port number, this is the host address that we would need. So we are told to make a note of this, but I'm not going to make a note. I'm just going to duplicate this tab so that when I need it I can come back to get those information. So let's keep going. So likewise, this instance has been configured with enable PG audit database flag already for us. So this PG audit, it's a popular PostgreSQL that provides detailed session and object audit login via the standard login facility, and we are going to enable PG audits on this our instance so that we can also monitor the performance of our instance. So let's keep examining this. So this is our instance. This is just the one that I duplicated, which is fine. So I can click on this action and edit. So this is just to examine it. We are not going to do anything at this stage. Under the advanced option, let's see the database flag. So this is the database flag that we have here. I'm just going to leave it like that. So PG audit has been enabled for us. It has been added. You can decide to add some database flag and see from the options whereby we can add from. Okay, so let's just cancel out of this. We don't need to do anyone now, and let's cancel out of this. So we've just done a spot check of our cluster and our instance at the moment. So let's keep following the instruction. So the next task is task 2, to set up a database extension. So we have to set up a database extension that work hand in hand with this PG audit feature for our AlloyDB. So this is not a case of configuring a flag. So when you are configuring a flag, you don't need to connect to the database, but when you are configuring extension, you have to connect to the database. So we have to connect to our AlloyDB client so that we can connect to our database to the AlloyDB client. So to connect to our database through the AlloyDB client, we have a virtual machine that has been created for us. So we can access that virtual machine by going to our compute engine. So from compute engine, we'll go to our virtual machine. Let's click on virtual machines. So here is our virtual machine, and we just need to SSH into our AlloyDB client. So let's SSH into our AlloyDB client. So it's transferring the necessary SSH keys to the virtual machine, and we are going to authorize our access. So we've authorized our access, and we are now establishing connection to our SSH server. So here we are on our AlloyDB client. So the next thing we are going to do following the instruction is to export this AlloyDB variable. So we are going to pass our private IP address of our AlloyDB inside this environmental variable, and in the next command we'll just persist it in the virtual machine so that we can be using it while we're on those virtual machine. So let's click this, then we'll paste this code. So we have to replace this AlloyDB address with the private IP of our AlloyDB instance. So we can get this from here, from this private IP address, and make sure you don't copy the port number like I mentioned. So if we copy the port number with the IP address, it's going to throw an error while connecting. So I'm just going to grab this, paste this here, then click on enter. So the next command, which is to persist this AlloyDB address that we've passed inside this environmental variable inside this text, so that we can be using it in this lab. So I'm just going to grab this guy, then paste it here, click on enter, and that's done. So the next thing is to enter into our PostgreSQL client. So the PostgreSQL client, we log into it with the PSQL command, and this flag H is to pass the IP address, which is the host name, and this flag used to pass in the username, and the username in this case is Postgres. So let's grab this command and paste this here so that we can launch into our PostgreSQL terminal. So we are prompted to put a password. So this has been created for us, and they used this password previously. So like I mentioned, all these things that have been provisioned for us are things that we've done before in the previous series of this lab. So make sure you take a look at them so that you can have better understanding of what we are doing at the moment. So we are inside our PostgreSQL. So let's go into our Postgres database. So now we are in our Postgres database, and let's run a command to create our extension. So this creates extension if not exists pgaudit. It's just used to install the pgaudit extension in our PostgreSQL database, and it is a very, very useful extension for auditing database activities and tracking user action. So let's just run this command. So it has created the extension, which is what we want. So we can take a look at the extensions that we have. We can first take a look at it with this command /tx to see the extension that are installed and that are running, to see the extension that are installed and are running. So if you take a look at this, we have this pg audit here, and it's running, so which provides auditing functionalities, and the version here is 1.7. So this is not part of the lab. This is just a code that I just ran to view the installed extension. So these ones have been created for us before. Yes. So the next thing is to run this command to also see the pgaudit extension that we installed. So let's just run this command. So it's more often than not does the same thing with this previous one that we used here, because we can see the pgaudit extension from here, and we can see the version 1.7. So let's also use this command. What this command does is that it selects the extension name and the extension version from the pg extension, pg_extension table, where the extension name is pgaudit. So let's see. So you can see that it returns the pgaudit extension name, and the version is 1.7, similar to what we got here, same thing. So that's about that. So we can now close out from our virtual machine at the moment. So we've enabled the extension that we want to do at this particular time. So let's exit our cloud shell. Let's exit our virtual machine rather. So let's confirm our progress. We've confirmed our progress. So for task 3, we have to create a read pool instance for an existing cluster, and we are just going to follow the instruction here. So let's go back to our AlloyDB. Here we are on our AlloyDB. Let's click into our instance. Click on add read pool instance. So this is where we are going to add our read pool instance, and this read pool instance is very, very necessary if we are going to use our database for an analytics workload, because the read pool instance gives better support for data analytics workload than our primary instance. So let's just create a read pool instance, and we are going to name it lab instance rp1, and we'll set the node count to 2. So let's paste this here, and our node count is set to 2. So we're also going to change the machine type to this 2 vCPU and 16 gigabytes. Let's see other information that we have to do. So that's all for now. Then under the advanced configuration, we are not setting anything at the moment. Then we can create our read pool instance. So it takes like 8 to 11 minutes for our read pool instance to get created. So I'm just going to fast forward this and see you at the end. Yes, so our read pool instance has been created, and it took around 7 minutes to get created. Yes, so we are done with that, and you can see it here. This is the read pool instance that we created, and it also has its own connectivity information. So this is our primary instance. It also has its own connectivity information. So you can see that the read pool instance and the primary instance, they are on a similar IP address. So not the same thing, just a similar one. So we have a last part just changing, which shows that there can still be connection between themselves, direct connection, because they are on the same range, and they also come with the same port number. So that's regarding that. So let's keep following our instruction. let's see if we've completed this task. Yes, so task is complete. For task 4, we want to set up backups, and automatic backups are configured by default when every AlloyDB is created, but we can also create on-demand backups for additional recovery options based on our workload requirements. So we are going to create an on-demand backup. So our instance was created pretty recent, and we can't have an automatic backup at the moment created for us. So we have to do an on-demand backup by ourselves. So let's go to our clusters. So you can see this is our primary instance, this is our read pool instance. This is the node that we set there at a particular time. So this is high availability. It has multiple read nodes, and just a quick overview of it. So let's set up a backup, and let's click on backup. So we have our backups page here, and we can click on create backup. So we have to create a backup for our primary instance. So following the instruction, so the lab cluster is our source for the backup, and our backup ID is this lab backup. So I'm going to use this, and I'm going to just remove the preceding white space. Then I'm going to create our backup, and you can see that our backup should be created in no time. It will take around like 1 minute. I'll just fast forward it and see you at the end. Yeah, so you can see our backup has been created, and you can see it's in a created stage, and this is our clusters, this is our backup here. So let's run a command to see the backups that we have created for this our AlloyDB cluster. So let me reconnect to my Cloud Shell, then grab this command here. So my Cloud Shell got disconnected, that's why I'm reconnecting. So on our Cloud Shell, let's run this command. I'm just going to authorize this. So, yeah, and this is the backup that we have on our instance. So you can see this is the backup that we created, and it's in a ready stage. This is the name that we use, the lab backup, and it's in a ready stage. So I think we are good to go for now. And you can also use this restore backup here to restore our backup, but we are not going to restore any backup at the moment now. So you can click on restore, but we are not going to restore any backup at the moment. Let's just cancel out of this, and that's pretty much for setting up backups. So I think we are also good. So for the 5th task, which is to examine monitoring in the AlloyDB. So we have the AlloyDB monitoring dashboard. That's a great tool for information about the usage, the size, and the performance of the clusters and instance. So this dashboard typically displays the metrics of the resources that we use, and let us monitor any trend or results of anything happening on our AlloyDB database. So let's set up our monitoring and see some of the things that we can make information or make sense from our monitoring dashboard. So in the cluster overview, so let's go back to our cluster, and let's go into our cluster. So this is the cluster overview page, and this is our monitoring dashboard. So we have different metrics that we could check for here, and so I'm just going to follow what the lab asks us to use. So at the moment, there are just little activities going on our dashboard at the moment, so we cannot really see much of a synthetic data set and simulate some workload on our instance, so that we can have some metrics showing up on our dashboard. So we are going to go back to our AlloyDB client, which would help us connect to our AlloyDB database, and let's simulate some workload there. Then we'll come back to our monitoring dashboard and see if we have changes. So let's go to our virtual machine pack. We are still our virtual machine here, and under AlloyDB, let's SSH into our AlloyDB instance. So it's transferring the necessary SSH keys. Then it will connect to our SSH server once again. And here we are on our AlloyDB client. set up the AlloyDB environmental variable by running this command. So we are going to get this from this cat AlloyDB ip.txt that we had before, and we can just do this command, and you see that it would come here. Then we can now try to echo our AlloyDB. Let's try to echo AlloyDB and see what's there. And you can see that this is the host name that we had previously. So when we save this inside this text, we can just get it from this text and take it back to this variable. So when I now echo this variable, you can see I have it here. So I think that's fine. So the next thing we have to do is to connect to our PostgreSQL, and we are going to create and populate a sample table with this command. So what this command typically does for us is that it's going to connect to our PostgreSQL server specified in the AlloyDB variable using the username. So you can see we are passing, so we are going to connect it to it using the host name that we've saved inside this inside this variable. Then we are passing the username flag, and the username we are using here is Postgres. Then also it's going to initialize the database with the specified scale factor. In this case, we are using a scale factor of 50, and we are using a fill factor of 90. So we are passing this I to initialize our database. The scale factor is 50 and the fill factor here is 90. Then we would run a benchmark test against the Postgres database to measure the performance metrics such as the transaction per seconds, the TPS, and latency. So that's what this command is just doing. And let's copy this and paste it here. So we have to use our password to have this information done. So here's our password here, and you can see it's doing it. It's still running. It's creating the tables for us. So it has done everything that we asked us to create, and it created some tables for us. So we are just simulating some workload on it. So what we just did, the largest table, pgbench account, it's going to load the database with 5 million rows, and it happened just fast. So the next thing we'll do also, we'll connect to our PSQL client so that we can now verify if the simulated load that we've done is actually on our database. So let's go to the PSQL terminal and connect to our database using the normal way we do connect to our Postgres terminal. So we have to paste in our password once again. Let's copy this password. Then we have it here. So the next thing we have to do is let's see the amount of data we have on our pgbench account. So I'm just going to run this, and so you can see we have 5 million rows at the moment, and we have 5 billion rows. So this is the amount of data that we simulated inside. So we can exit our PSQL client now. We've exited our PSQL client. So the next thing we are going to do is using a similar we are going to run the following pbench operation to simulate some workload against the lab instance. And using this code, this is typically what we'll be doing. So this operation is going to load 50 clients across 2 threads, pulling every 30 seconds over the course of 3 minutes. And we'll also be prompted with our password before we can run this command. So a little breakdown of what this command does is that it connects to the database on the server as specified using this host name, using this username, and after that it would gradually increase the number of client connections to 50 over a period of 30 seconds. So it will increase the number of connection to 50 over a period of 30 seconds, and it's running on 2 threads like we explained before. So it's also going to run the benchmark for 180 seconds, which is like 3 minutes, using 2 worker threads and 50 client connection. And the output will just be the result of the benchmark test that we did, including maybe metrics such as transaction per seconds, latency, and other performance indicators. So let's run this command here and see what's going on. So we are prompted to input our password again. Let's grab our password here, paste our password here. So it's initiating the workload. So we are just doing all this so that we can now monitor some of the metrics on our AlloyDB. So wait for this guy to be done. So it typically take like 3 minutes for what we are doing, because the specification is to increase the number of client connections to 50 over a period of 30 seconds, and it's going to run this benchmark for 180 seconds. That's for 3 minutes. Okay, so that's and the result should look like this. But let's wait till we are done. And fast forward it and see you at the end, so that we can. Now we are done, and we can see that it was typically increasing the connection after every 30 seconds. So from 30, 60, 90, 120 till it got to the end, which we were telling it to gradually do this increase for 3 minutes. So the duration of this was 180 seconds, which was 3 minutes, and the number of transactions actually processed is 237,978. Then it took this latency average and the latency standard def and the initial connection time and the TPS time. So without the initial connection time, so it just showed some metrics that we also like asked it to show for this particular simulated workload. So that's about that. So now let's go to our dashboard and go and view some of this information and look at how the graphs has changed. So going back to our lab overview, so we can just see the details on mean CPU utilization, and now let's view it for 1 hour, so that we can have more granular view of the effect of what we are doing. So you can see from when we started this thing around this time and how it was pulling up till it got to 100% CPU utilization here. So you can check the marks, you can just see the time here, you can see how the metrics are changing, the database load. So these are just minimum available memory, and the one that we also have as the one on the read pool instance and the one on the primary instance. So these are, you can take a look at all these things here, but let's go down to the query insights. So let's go to the query insight and see what's going on here. So the query insight is from this left hand menu, our query insight, and we can see the load by total time for this update pgbench branches. So the operations that we did, you can see how it took time here, and we've already sorted it. So it's sorting by descending here. So you can see the average duration of these, the time scored, the amount of row return. This was when we inserted 5 million data, 5 million rows inside our Postgres database, and other information that we did here, and how they took a whole lot of time. So that's just a little bit of how we can explore the monitoring part of our AlloyDB and see if our database is optimal, and how we can make sure that our database is in an optimal condition. And we can also estimate the amount of time it takes some queries to run, the amount of time it takes for things to happen, and how this can be viewed here. Pretty much everything we are supposed to do for this lab, and thank you very much for staying through to the end of this lab. So we've performed administrative tasks that are essential to the optimal use of our AlloyDB for PostgreSQL database. So if you enjoyed this lab, make sure you give it a thumbs up, comment your thoughts in the comment section, and share with your loved ones. And don't forget to subscribe to my channel, and make sure you turn on the notification bell so that you don't miss any other video from our channel. Bye for now, and see you in our next lab.